following is a demonstration of IBM's next-generation hybrid transactional and analytics processing database engine. Some key features we'd like to demonstrate today are the extremely fast ingest rates that can be achieved, the ability to run analytics queries while ingesting data, integration with IBM Watson Studio to allow for the creation and use of machine learning models, and integration with data virtualization to enrich our analytics queries. To demonstrate these features, we've imagined a scenario in which sensors have been placed on the Golden Gate Bridge to monitor the bridge's structural integrity. There are various sensors to monitor things like tension, vibration, and load. The sensors have been placed on each of the bridge's vertical suspension cables, and we've grouped the cables into 5 groups to reduce clutter on our graphs. Looking at our dashboard for this scenario, in the top left we have a graph showing our ingest rate measured in events per second, which translate into rows per second. At the bottom left and top right, we have some graphs which show the results of some analytics queries that are computing things like average and maximum live load, maximum vibration, and maximum tension over the last 5 seconds. At the bottom right, we have some dials showing our machine learning model's prediction for cable failure based on the vibration readings from our sensors. We can see how our model behaves by simulating an earthquake. In this case, we simulate an earthquake that has a magnitude of 8.0 and lasts for 15 seconds. As you'll see, the model predicts a higher chance of cable failure as a result of the increased vibrations. Let's have a look at how our model was created. To create our machine learning model, we created the following notebook in IBM Watson Studio using Python. The code for our model first connects to our database engine. Once connected, we can access tables, viewing their schemas, and querying them. In order to create our model, we use some Python machine learning libraries. In this case, we use a simple linear regression library to predict cable failure based on vibration data that we've seen in the past. Once the model is created, we can then deploy the model. Here you see we have an endpoint URL which we can use from remote applications to access our model. We can also use the model directly from the notebook, as you can see here. We can further enrich our model and improve our analytics capabilities by bringing in data from other sources with the power of data virtualization, which we will see next. Here's a look at the data virtualization user interface. This particular page shows the various data sources that we can query. In this case, we have 3 DB2 data sources as well as 2 MySQL data sources, all of which can be queried through the data virtualization user interface. For example, we can create a notebook in which we query the individual data sources. Here we query the tension table as well as the vibration table from one data source. From another data source, we can query the manufacturer cable dimension table. Even more impressive is the ability to query tables from different data sources in the same query, treating them as if they were part of the same data source. Here's a query in which we join the vibration table from one data source and the manufacturer cable dimension table from another data source. Here you can see the result of the query and some graphs that we can produce through the user interface.
We are working with IBM Research to make data more widely accessible by leveraging natural language-based interfaces to query DB2 databases. This technology will take English questions and generate complex SQL statements. The natural query techniques shown in this demo interprets the input statement against a domain schema that includes the entities and their relationships, capturing deep domain knowledge. Natural language can be used to query various aspects of the sensor data as well as dimensional data for each cable. Pre-selected queries can be clicked on to issue the query. In addition to the listed queries, you can type variations directly into the query bar. The generated SQL can also be inspected. In this example, we can see a join against a nested subquery.